Okay. Dear cadets, let us see the steps involved in finding the Bode plot of this given function. So given function is gh of s is equal to 10 upon s into bracket s plus 1 into s plus 10. Step number 1 is we have to represent the equation in something called as standard form. So I am skipping those steps and this becomes a standard form. gh of j omega will be equal to 1 divided by j omega into bracket 1 plus j omega into multiplied by 1 plus j omega by 10. Now we have to arrange the equation in something called as ascending order of corner frequencies. So the factors are pole at origin, that is 1 divided by j omega. Next factor is finite pole, so first order pole, which is represented by this factor 1 upon 1 plus j omega, and the third factor is first order pole, which is represented by 1 upon 1 plus j omega by 10. So we wrote down the factors in the ascending order of corner frequencies. So for factor 1 upon j omega, the magnitude curve will be a straight line of slope minus 20 dB per decade passing through omega is equal to 1. Phase curve phi will be equal to minus 90 degrees for all values of omega. 1 divided by 1 plus 0 omega, so line slope will be 0 dB till omega less than 1 and minus 20 dB per decade for omega greater than 1. Phi will be equal to minus tan inverse omega 1, and third factor is 1 divided by 1 plus j omega by 10. Line slope will be 0 dB for omega less than 10 and for minus 20 dB per decade for omega greater than 10. Now we need to transform this information onto this graph paper called as semi-log graph paper. Now the important frequencies are in the range of 1 to 10. So I'll take the frequency of 1 over here, 10 over here. So this becomes 100, this becomes 1000, this will become 0.1 and this will become 0.01. The idea is that the frequencies of interest should lie in the center region of the graph paper. Accordingly, this has been chosen. Now this graph paper will get divided in two parts. The lower part will be used for phase plot and the upper part will be used for magnitude part. We will choose the scale accordingly. So let's say till here will be my, from down below will be my magnitude part and this will be my phase plot. So so this is omega axis and this is dB axis. So this will be plus 20, this will be plus 40, this will be 60 and this will be plus 80. Likewise this will be minus 20, minus 40, minus 60 and this will be minus 80. Mind you, these all are magnitude expressed in dB. Okay, so the first factor is 1 divided by j omega. At omega is equal to 1, so that means over here the magnitude is 0 and the slope is minus 20 dB per decade. So as the frequency increases by 1 decade, that is when it becomes 10, the slope has dropped down by minus 20. So that fixes up my line. So here is my line. It will extend, say, till here. So I will say that this line represents my factor number 1, which is 1 divided by j omega. Let us speak about factor number 2. Right, so factor number 2 till omega is equal to 1, it will be a line of 0 dB, and after that line will have a slope of minus 20 dB per decade. So this line from this point onwards represent my second factor, which is 1 divided by 1 plus j omega. Now third factor is 1 divided by 1 plus j omega by 10. So this line will be 0 dB for omega less than 10 and will have a slope of minus 20 dB per decade. So as the frequency goes from omega is equal to 10 to omega is equal to 100, this line will drop down by minus 20. Okay, so this represents my factor number 3, which is nothing but 1 plus j omega by 10. Okay, now is the time to construct the resultant. So I have got three factors. This is factor number 1, this one is factor number 2, and this one is factor number 3. Okay. Now the resultant will have a slope of minus 20 dB per decade till this point, because only one factor was prominent. Now beyond this factor till this frequency, right? These two factors were coming in picture, so the resultant will have a slope of minus 40 dB per decade. Okay. So from this point onward, I am trying to sketch a line having slope of minus 40 dB per decade. So as the frequency goes from omega is equal to 1 to omega is equal to 10, the line will drop from 0 to minus 40 dB. So here is the point. Okay. And after that all three factors will come in picture. So the resultant, so this is a resultant with a slope of minus 40 dB per decade. Okay, beyond this point the resultant will have a slope of minus 20 plus minus 20 plus minus 20, so therefore effectively minus 60. Okay, so therefore as the frequency will increase from 10 to 100 radian per second, the line will start from minus 40 and with additional minus 60 it will go to up to minus 100. So somewhere over here will be minus 100. Okay, so I have to join these 2 points, but below this will be my phase curve. So I will not draw the entire line, but I will sketch it till here. Okay, and I will say that this line has a slope of minus 60 dB per decade. Now there are some very simple thumb rules. Now this line has a slope of minus 20 dB, this line has a slope of minus 40 degree, and this line has a slope of minus 60 dB per decade. It is quite evident that if you look at the lines, this line is much steeper compared to this line, and this line is much steeper compared to this line. So as the slope increases, from minus 20 to minus 40 to minus 60, ensure that your line starts looking steeper and steeper. If the line doesn't look steeper, safely assume that you have committed some mistake. So this will be the resultant. Okay, plotted below over here will be the phase curve.